In the previous lecture, I discussed phenomena associated with sunrise and sunset, and the beautiful colors that you can see in the sky, the clouds, the sun. Here, for example, is a red sun, clearly a sun that's setting in a very dusty atmosphere where a lot of the light is being scattered and absorbed. Okay? Well, the sun, of course, rises in the east and sets in the west, as do the stars, and we discussed sunrise and sunset. And here you can see a visual, an animation of this process where all the stars and the sun set in the west, stay below the horizon for about 12 hours, the length of time depending on your location on Earth and also on the season. We'll discuss those factors later. And then rise again in the east and go across the sky. This so-called diurnal cycle, this 24-hour cycle, is of course caused by the rotation of the Earth about its axis. The Earth is spinning like this. It's spinning about its axis, and that process takes a full 24 hours. And we're standing somewhere here on Earth looking out, and of course as the axis spins, our perspective changes. So we see different parts of the sky. And so as the Earth spins from west toward east, the sun and the stars rise in the east, move across the sky, and set in the west. That's the cause of the 24-hour day-night cycle. It's not that the sun is orbiting the Earth, okay? A lot of people, for many thousands of years, thought that that was the cause of the day-night cycle. The sun is orbiting the Earth, moving around the Earth. Well, that's not true. The Earth is, of course, moving around the sun. The Earth is orbiting the sun. But that is the cause of the year. That's the 365.25 day year that the Earth's trajectory takes in its orbit around the sun. So it's important to distinguish an orbit from a rotation about an axis. Now, the fact that the Earth is spinning about its axis, causing the 24-hour day-night cycle, is hardly earth-shaking news nowadays. You know, most people know this. But occasionally there are still some headlines, especially in newspapers that like to sort of spoof or make parodies of common phenomena, you know, give them in really sensational sort of terms. And in fact, there's a parody newspaper, a weekly parody newspaper that you can find on the internet or published in print called The Onion, and it had this amazing headline, "Rotation of the Earth plunges the entire North American continent into darkness." You know, it was kind of a fun headline to see, and they tend to do all sorts of headlines like this about common everyday phenomena. But it's amazing that, in fact, a lot of people don't know that this is the cause of the day-night cycle, or that the Earth orbiting the sun causes the year. Well, now that the sun has set, let's start looking at the stars, and we'll start with a discussion of the constellations, groups or patterns of stars that are easily visible in the sky. Now, there are 88 constellations in the sky, mostly of ancient Greek and Egyptian and Chinese origin, and these are familiar looking patterns. Some are a bit hard to distinguish, others are quite easy. There are now some more modern constellations, especially in the southern hemisphere, such as Telescopium. Now, Telescopium couldn't have been an ancient Egyptian or Greek constellation because, you know, the telescope wasn't invented until the early 17th century. But most of them have this origin, and there's a lot of mythology associated with them as well. Some are easily recognized, like Orion, the great hunter. And Orion is shown here. Anyone can visualize the belt, a shoulder there, another shoulder there. The head is this little grouping of stars. One foot is there and another one is right there. And the sword is hanging below the belt. And Orion is holding a club up here, sort of off of the screen, and either a shield or a lion that the hunter managed to vanquish, holding with the other hand there. So Orion is perhaps the brightest constellation in the sky and is really quite easily recognizable by most people. Now, another one that looks a lot like the thing it's named after is Scorpius, the scorpion. And here's an enhanced view of it. You can see the body arching down like this to the tail, and then the stinger right there. and the pinchers are up here. So this is Scorpius the Scorpion. And this is actually an enhanced view. The main stars of the Scorpion here have been enhanced relative to the other stars to make them more apparent. The area in which Scorpius sits is so rich in stars that it can actually be a little bit hard to recognize it when you have a long exposure that shows all these other fainter stars. But Scorpius looks like a scorpion. And the mythology, as I mentioned, can be kind of fun. For example, in Greek mythology, Orion was a great hunter, a huge, wonderful hunter who was rather arrogant, actually. He thought he was the greatest hunter in the universe. And this sort of annoyed a lot of his friends and stuff, and they sort of thought he was just too arrogant for his own good. And the Scorpion in particular was pretty annoyed by this and started stinging him repeatedly. And Orion supposedly battled the Scorpion for several days, but ultimately lost and died, okay? So Zeus took pity on Orion and put him up in the sky for all to see forever after. But the Scorpion was also put up in the sky as a constellation on the opposite side of the sky so that the Scorpion and the Great Hunter would never again bother each other. Okay, they'd never get in each other's way. So as the Scorpion is rising, Orion is setting, and vice versa. Okay, you never really see them at the same time in the sky. But in different cultures, the mythology can be different. For example, the native Hawaiians say that the Scorpion is a giant fishhook, a fishhook of the demigod Maui. And as Maui was fishing with his brothers off of an outrigger canoe, he was pulling the fishing line, and this fishhook, you can see it kind of looks like a fishhook, and Maui was pulling the Hawaiian Islands out from underneath the ocean, okay? And then his brothers looked around. He told them not to look around until he was done. They looked around, and this stopped the process, and so the Hawaiian Islands are a rather small chain instead of a great land the way the demigod Maui wanted them to be. So that's an example of some of the mythology, which is kind of fun to learn about. Another constellation that looks a lot like what it's named after is Leo the lion. Here is the head, this backwards question mark. Then the body stretches out in this direction, and then the tail is out over here. And again, this is an enhanced view where the main stars of Leo have been accentuated relative to the other background stars. Generally, constellations are named more in honor of something rather than because they explicitly resemble that object or that entity. And a good example is Ursa Major, the Great Bear, shown here. Now again, this is an enhanced view where the main stars of the Great Bear are brightened relative to the surrounding backdrop of stars. And here is sort of a bear drawn in the same field. And I don't know, I can't really see a bear there, all right? You know, anyone who can see a bear there either has a very vivid imagination, much better than mine, or is hallucinating on something weird, you know, or I don't know, you know, I can't see a great bear there, Ursa Major. But in any case, Ursa Major is one of the more prominent constellations. It's a big constellation in the northern sky. A lot of us are very familiar with part of the Great Bear, an asterism, a grouping of stars that is not itself a full constellation, but is part of a constellation. And this particular asterism is the Big Dipper, okay? That's easily recognized in the sky. There's the handle of the dipper, and here is the bowl. All right, and this is a pretty bright, easily recognized asterism, not a full constellation. So a lot of people think that the Big Dipper is the Great Bear. It's really only part of the Great Bear. The handle of the dipper is the tail of the bear, but most of the bear goes off to the right of the bowl here. So that's an asterism, easily recognized. The two end stars here of the bowl are known as the pointer stars. They're the pointer stars because they roughly point toward the North Celestial Pole, the North Star, about which I'll have more to say in a few minutes. But here is Ursa Major and the Big Dipper outlined within Ursa Major. And here are these two pointer stars that roughly point toward Polaris, the North Star. And Polaris happens to be the end of the tail of Ursa Minor, the small or minor bear, which also has an asterism within it, the Little Dipper, shown here. Now the Little Dipper is actually pretty hard to see in the sky. Here's a view that is not enhanced. There's Polaris. There are the two end stars of the bowl. All right, those are the easily visible ones. And then the other ones are this one right there, that one there. That's the two other end stars of the bowl. And then we go off into the tail. There, there, and then to Polaris. That's pretty hard to identify. Here's an enhanced view of the same asterism where you can see it much more clearly. Of course, Polaris is easily seen, although it's by no means the brightest star in the sky. It's actually relatively faint as far as the bright stars go. Here are the two fairly bright stars at the end of the bowl. Here's the rest of the bowl, and then there's the tail. So a lot of people have seen the Big Dipper. Fewer have seen and recognized the Little Dipper. And once again, who can see a bear in this collection of stars? I mean, if you can see a bear, then you've got a better imagination than I do. All right, well, let me tell you a few interesting things about the brightest stars in the sky, a few of the brightest stars. I'll start with Betelgeuse, the left shoulder of Orion. This is an enormous star. Its physical size is absolutely astonishing. Here's an actual picture of Betelgeuse taken with the Hubble Space Telescope, where it no longer looks just like a point like most of the stars look like. It actually is resolved. You can see that it spatially takes some physical extent. It's not just a little point like these things there. And if you superpose on this diagram a physical scale, you can see just how big the star is. Here is the size of Earth's orbit, okay? Twice 93 million miles, because this is twice the radius is the diameter. There's the diameter of the Earth's orbit. Betelgeuse is way bigger than that. Here's the diameter of Jupiter's orbit. Jupiter is about 5 times farther from the sun than Earth is, so there's its orbit. You can see that Betelgeuse is about the size of Jupiter's orbit around our sun. So that's a really magnificent star, and we'll discuss it later. It'll explode later in its life. If you extend the belt of Orion down to the lower left, that is to the southeast, you come to the apparently brightest star in the sky, Sirius, the dog star. And here's a close-up photograph of it through a large telescope. It has a faint, small companion, which is known as a white dwarf. Now, a white dwarf is a dead star. Our own sun will become a white dwarf in about 6 or 7 billion years. It's the compact remnant of a star that has lived out its life, and roughly half the mass, or up to the same mass as the sun, is compressed into a volume about the size of the Earth. So the material in a white dwarf is really dense. A teaspoonful of it would weigh something like 5 tons if you had it here on the surface of the Earth. That's a white dwarf, and we'll discuss these stars a lot more later. I'm just telling you a few tidbits to whet your appetite for what's to come. Now, as I mentioned, a lot of people think that Polaris, the North Star, is the brightest star in the sky. Far from true. It's actually relatively faint as far as they go. And here in this diagram, you can see Ursa Major, the Big Dipper, with the pointer stars pointing approximately at Polaris. It turns out that Polaris is pretty representative of stars in that it is not a single star, it's 3 stars. Now, most stars in the sky are either double or triple or quadruple stars. You just don't see that because your eyes don't have the clarity of vision, okay? But if you could look at them through a telescope, you would see that there are 2 or 3 stars. And the 2 main components of Polaris are pretty easily separated with the Hubble Space Telescope, Polaris A and Polaris B. But Polaris A itself has a close companion, which requires very sharp optics to discern. There it is, Polaris uppercase A, lowercase b. So this is a triple star system, and they're all orbiting around each other. This is pretty common of stars in the sky. All right, another interesting star that is easily visible in the sky is Vega in the constellation Lyra, the Harp. Here's Vega in the constellation Lyra. It is one of the brightest stars in the sky, not quite as bright as Sirius, but still very bright, and high up in the sky during summer months. Indeed, it is one of the stars of the so-called summer triangle. There's Vega in the Harp, Deneb in Cygnus the Swan, often called the Northern Cross because you can